Hi and welcome to another 5-minute session, and this time it will be about the texture Voronoi. So I press Shift A, go to texture and select the Voronoi texture. To explain Voronoi, I do like this. I take this to 2D and then I copy this by pressing Shift D, and I will take those and compare them. So I use a minimum, so Shift A, and then I use a converter, math, and here I select the minimum. And the reason for this is because here we have lots of dots. If I change this to distance to edge, we have a lot of edges. If I combine these with the minimum, you can then see what happens. So it drags a line or draws a line exactly in between two of these lines or two of these points, and the same here. So if you have a long distance between, it takes a while before the line is drawn. If they are like really close, then the line comes really close to these two. So it compares those two. Okay, so that is the Voronoi texture, and now we can look a bit closer on it. So 2D I used because now we only work in x-axis and the y-axis. If I work with the 3D, you can see that you get someone that is closer and some that are really far away using more of the z-axis. So that depends how you would like to present it. Then you have different patterns. So now we are working with circular pattern, but you can work with stars, or you can work with the other direction and Minkowski, which are a way of changing how this pattern can look by changing the exponent here. So those are the different types you can select. Normally you just use the Euclidean if you want circular shapes. Normalize range 0 to 1 without there is a risk that it's below 0 and above 1. Scale is the scale. Detail you can drag up here, and detail is depending on everything else here. So lacunarity is like the layers, you can say. So right now we have one single point here. If I take up this, you can see it changes a bit here, and that is because I add layers to this, so like smaller circles above that. And you can see that when I drag up the detail a bit and the roughness, and I take up the lacunarity here, you can see it shapes into smaller circles here. So now we have a lot of small circles because every step we take with the lacunarity adds a new layer with smaller and smaller points. So now we have a lot of points here, and how we mix these together, that is the roughness here that controls that, and the detail. So a lot of detail, then you get a lot of sharpness on all these small circles, and with less detail but with high roughness you can then mix the brightness and the contrast. So high detail, a lot of small circles if you have a lacunarity that's high, and with a high roughness it gets clear because you mix these together. So that is the different types of parameters to have to play with to get everything as you want. And what we can do here is also go through these. So F1 is the standard. We can do like this, that we can just erase that and take this one. So we start from the beginning, it's easier to see. Some detail, and now you can see we get more details, also more lines here. Yes, so we have the F2. The F2 is almost more like lines because it combines those two dots into one single dot, and that it becomes more like a rectangular thing. So that is how that works. Smooth F1, it's smoothing out the edges, so you get a softer edge and softer point, but otherwise the same as the F1. Distance to edge is the distance we have, and then we have the n sphere radius that I quickly can show you. So if we have the same scale here, we can do like this. If I use the less than, put that in here, and I change the threshold, you can see that if I use F1, I get these smaller, smaller, bigger, bigger, but here you can see they are overlapping. Here we can then use n sphere radius. If we use that, we never overlap, even if we go up with scale. So that is really good to use to separate them so they don't overlap. Now I have done this for a little more than 5 minutes, so I think I end here and you can play with it yourself. See you tomorrow and bye for now.